Again, if you are now given, you are asked to find the log of a number that has a power. Let's use the number we've used before, like log 28.53. Okay, we are now asked to find log 28.53. 28.53 0.53, maybe raised to power 2. Okay, do you remember the laws of logarithm? We are going to use it here. Do you remember the law that states that if you have to find the log of any number raised to a power, is the same thing as multiplying the log after getting the log of the number by the power? Do you remember? So that's what we are going to use here. So it's the same thing as we'll first find log 28.53 after you multiply it by 2 using the laws. If you are not yet conversant with the law, you go to, I have a video on that, you check back. So meaning that once you've known the value of this, if you multiply it by 2, that's the same thing as getting the log of 28.53 raised to power 2. So from what we've solved before, we know the value log 28.53 is 1.4553. 1.4553. So this is 2 times 1.4553. So which is 2 times 3, 6, 2 times 5, 10. 2 times 5, 10 plus 1, 11, 1, carry 1. 2 times 4, 8 plus 1, 9. And 2 times 1, 2. How many? 1, 2, 3, 4. 1, 2, 3, 4. So that's the answer. So that's it. So the same way, if you are asked to, maybe if you are asked to find log 3 raised to power 1 over 6. So the same way, this is 1 over 6 times log 3. I will know we've gotten the log 3 as 0.4771. So meaning that if we have nth root, we divide. You know, this could be written as 6th root of 3. 3 raised to power 1 over 6 is the same thing as 6th root of 3. That is the same thing as 6th root of 3. So whenever you have nth root, you divide by the index here. So the log of it, you divide by, I'm saying that it's the same as 0.4771 over 6. So you don't need to just divide. If it's, so you divide. So let's divide. 0 in 4 is not possible. So 0 in 47. 7 remainder 5, I think 5 in 57, 9 remainder 3 in 31, 5 remainder 1 in 10, should be 1 remainder in 46. But remember, this is 4-figure table. This should be 0.07952. We stop after after the first 4 non-zero digits in the decimal part, or if it's a whole number. 2 exceed 4 digits, that's 3-digit number after the decimal point. So that's it. To find the log of 0.002, I'm using the ones we've solved before so that it will be easy. 0.02, 0.02345, 0.02345, 0.02345. So 0.02345 raised to power half. because I want to teach. This one is easy, but if it's half raised to an nth, if you are asked to find the nth value of it, nth root of it, is harder. So we know that this is now half log 0.02345, and we know that's it. What's the value? Bar 2.3701, and I told you can split it as minus 2 plus what? 0. Bar 2.3701. Bar 2.3701. Bar 2.30. Sorry. 3701. 3701. 3701 over 2. Okay, to solve this is easier compared to, but I will still solve something like this, but this one, here the nth root here will be greater than 2, so you will learn something new again. So we can easily, I told you this can be written as, it's like we are splitting now. Bar 2 minus 2 plus 0.3701 over 2. And we know minus 2 over 2 is 1, minus 1, which is bar 1. Which is bar 1. Bar 1 plus 2 in 0, 2 in 3, 1, remainder 1. In 17, 8, in 10, 5, in 1, 0, and in 10, 5. So which is minus 1 plus this is bar 1.18, and I told you approximate 1 is 5, 1. So that's our answer. But assuming we're asked, look at this, we're asked to find log 2, that same 0.02345, 0.02345 raised to, maybe let me use power of 1 over 3. We know that is we solve it as 1 over 3 log 0.02345, and we get the log. The log is bar 2. Remember, I told you it's bar 2.701 over 3. But here, if you notice, this one is trickier compared to that one, the first one, because minus 2 is not, to get this is hard. So see, as mathematics, we can split this, minus 2. We can bring in minus 3. Remember, it was easier for us to divide this because this is minus 2. Minus 2 over 2 is minus 1. So we can bring in minus 3 and counter it by adding 1. So I'm saying that instead of writing this, I can write this as my bar 3 plus 1. Because if you do bar 3 plus minus 3 plus 1 is minus 2. Do you get? So this is now my whole number part plus that's 0.3701 over 3. Do you get the logic? Because that's the only way I can divide. I can't divide this directly. So I bring in any multiple of this, the negative part, but the easier one is minus 3. So minus 3 plus 1 will give me minus 2. That's the whole number part. Plus this is our mantissa part. So which makes the solution easier. So minus 3 divided by 3 is bar 1 plus, this is now 1 point. So I need to divide this. So this is divided by 1.3701 over 3. I've divided this. I'm trying to simplify this. So I added 1 plus this before the division. I've divided minus 3 over 3 to give me minus 1. So I need to divide this. So which is now about 1 point plus 3 in this is not possible. That's 0 point. In 13 is 4. in 17, 5, in 20, 6, in 21, 7. So my answer is now about 1.4567. So do you see the difference? So whenever you notice that you can't divide direct, you bring in the multiple of that number, the denominator, and counter it back. So that's the best way to do it.
Log table. So the antilog of a number is just the opposite of, or the inverse of logarithm. So if you want to go back, assuming you are given a log of a number, we've gotten the log already, and we want to know the actual number that gave us that log, we now use anti-log. When we use anti-log table. And how do you do this? It's very simple. Remember, when we wanted to, okay, let's go over to the log of a number. Remember, when we found log 28.53, we look up 28 under 5 difference 3. It gave us 4553. Are you following? Remember this one. How did you get this one? It was through standard form. So we don't focus here on the characteristics. So in getting the anti-log, we focus on the mantissa, because if you could remember, when we got this, when we look up this, we got 4553. So in getting the anti-log, we focus on 4553. We'll still use, I'll tell you when to use the whole number part. The whole number part is just to locate the decimal, the how many digit number here. That's the decimal, to locate how many digit number the number will be. So we just focus on the mantissa. So if you are looking up anti-log of this, so we want to get back 28.53. Do you get? So how do you do it? We go over to our anti-log table and look up 45 under 5 difference 3. 45 under 5 difference 3. So see the anti-log table, 45. So 45. Okay, remember I told you this is the 0.4, the mantissa part. So 40 under 5, 0, 1, 2, 3, 4, 5. Difference 3. Difference 3. This is 1, 2, 3. So you add plus 2. But this is 1, 2, 3. So we add. So plus 2 is now 2853. 2853. If you remember now, let's go over. Let's go and check. Let's go and check. We got 0, 1, 2, 3, 4, 5. So 2853. So let's check. So do you see it now? 2853. You'll be wondering, how will we locate the decimal point? It's very simple to locate the decimal point. Remember, when we converted this to standard form, since we have 2-digit number here, what do you have here? 1. Do you get what I'm saying? So meaning that the characteristic is always 1 down from the whole number of digits. So check the other one. Okay, 3. 3 is a 1-digit number. What do you have here? 0. Do you get? So why for 0.00, the bar determines the number of 0. If it's 2 zeros before a non-zero digit. If it's, remember, this is 2 0, that's why we have bar 2. If it's 3 0, bar 3. If it's 1 0, bar 1. So since I have, so always remember this. If the digits, if it's a whole number, that's a non-zero digit, is always 1 down from, you subtract 1 from the number of digits. This is 2, so if you subtract 1, you get 1. So since we have 2853, and what we have here is 1,
meaning the number must be a 2-digit number. So the answer is now 28.53. Remember, we read off 2853 before. So the same way, let's do the same thing with 3. If you are to find the antilog of 0.4771, 0.4771, so what we'll focus on the decimal part, which is 0.47. That's 47. So we'll look up 47 under 7 difference 1. Let's go. 47. Okay, see, under 7, this is 0, 1, 2, 3, 4, 5, 6, 7. This is 2, 9, 9, difference 1. Remember, 1. So if you add it, you get 3.0000. Do you see it? That's 300. Don't just neglect the decimal here. We get 30000. So we now check the digits, the characteristics. What is there? Is 0. Is 0. Since it's 0, meaning it must be a 1-digit number. So meaning 3.000. So that's it. Again, let's do for this. If you are to look up the antilog of, we want to get back 0.02345. So we now look up 37 under 0 difference 1. So let's go 37 under 0. 37 under 0. C under 0 is 2344. Difference 1 is 1. So if you add it, you get 2345. 2345. But there is a problem here. It's not a problem. Do you see 2345? Since we have bar 2 here, meaning there must be 2 0. So that's why, and 0 point. There's nothing like 0 point. So 0 point. So that's how you read up the antilog of a number. The antilog is just going back to the original number. So let's now go over to the main question here, which is now using it to simplify. Simplification of expression using logarithm table.